Now we will do the questions related to trigonometry with the SAT 1 and the other 10T test for this topic of trigonometry. So first of all, we will define the basic formulas for the trigonometry and then how they are being used in the different examples. We will sort it out. So trigonometry means the three angles measurement, and we started from the right angle triangle there. So if it is a right angle triangle A, B, and C, where this side is small a, this side is small b, and this side is small c, then first of all, sine of A is equal to perpendicular over hypotenuse. Sine of cos of A is equal to base over hypotenuse, and tangent of A there is equal to perpendicular over base. This is number one. Number two, if the two sides are known to you and you have to find out the third one in the right angle triangle, then base square plus perpendicular square is equal to hypotenuse square. So we can make it like that: b square plus a square is equal to c square. This is the basic formula for this right angle triangle for the measurement of the lengths of the objects there. Then for the third one, sine of A is basically equal to cos of 90 minus A, and cos of A is equal to sine of 90 minus A. We know that A plus angle B plus angle C is equal to 180 degrees. C is already equal to 90. So A plus B is equal to 90. So A is equal to 90 minus B, or B equal to 90 minus A. So this is the way that you can find out these things in this trigonometry there. Then we have the fourth formula there, because they are the similar triangles. Let's say triangle ABC is similar to the triangle DEF. Since they are similar given in the beginning, so we know that there are constant ratio between their respective sides. So AB over DE must be equal to BC over EF, and that is equal to AC over DF. And that thing is equal to a constant value K there, which is given to you. Then the second thing is, because they are similar, so in similar figures, the angles are always same. So angle A must be equal to angle D, angle B must be equal to angle E, and angle C must be equal to angle F there. So basically the angles are same, but the measurements are different. So that is why they have a constant ratio between their respective sides there. Then we can use the sine rule there. For this sine rule, we know one thing, that A over sine of A is equal to B over sine of B is equal to C over sine of C. We have already derived all these formulas in the trigonometry topic for this explanation there. Then we can use the cosine rule, that is equal to A square is equal to B square plus C square minus 2BC cos of A, or B square is equal to A square plus C square minus 2AC cos of B, or C square is equal to A square plus B square minus 2AB cos of C angle there. For any angle in this between this triangle ABC, if let's say we are going to find out cos of A there, so cos of A will be equal to B square plus C square minus A square divided by 2BC, or only angle A will be equal to cos inverse of B square plus C square minus A square over 2BC. And similarly, we can find out for the rest of the triangles for that angle calculation there. So these are the basic formulas which are being used in this trigonometry topic for this SAT 1, whether it is with calculator or it is without calculator there. Now we will have the different examples which will be explained here one by one so that you can have an idea about all this portion into this. Let's say this is the first problem we are going to find it out. There are two triangles given. Triangle ABC and XYZ are similar to each other. Then what is the value of sine of Z? So there are two triangles given to you. One is the triangle ABC where AB length is equal to 9. This thing is equal to 12 and this thing is equal to 15 given there. It is similar to this triangle XYZ. And we are going to find out the value of sine of Z there. Since we know one thing, that these two triangles are similar. So triangle ABC is similar to this triangle XYZ. So angle A must be equal to angle X, angle B must be equal to angle Y, and angle C must be equal to angle Z there. Here, sine of Z you are going to calculate. So Z is in this, so this is going to be calculated and it should be equal to perpendicular over hypotenuse. And here, because Z is similar to this C, so this angle is there. So that means sine of C is basically equal to 9 over 15, which is equal to 3 by 5. So sine of C is equal to sine of Z there, and that value is equal to 3 by 5. So this is the choice out of those four in this question there. Since we have already calculated this property that A is equal to 90 minus B or B is equal to 90 minus A, and sine of A is equal to cos of 90 minus A, and cos of A is equal to sine of 90 minus B. So here we can use it, that is sine cos of A is given there. So cos of A should be equal to sine of 90 minus A, which is equal to sine of B there. So sine of B must be equal to 3 by 5 because it is given in this. So you can have this choice for this question number 2 for that. Now question number 3. The three angles of a triangle have the measurement DEF. A similar triangle have the measurements T, U, and V. If F is equal to U is equal to 90 and T plus E is equal to 90, then sine of D is equal to 0.8. What is the value of cos of U there? So you have seen it in this case that cos of U, you are going to find out where the rest of the informations are given. So the triangle DEF, and there is another triangle UTV, where angles are equal. So you have made this thing as F is equal to V, which is 90. And they said that triangle DEF is similar to the triangle UV and T. Then according to this should be the T part and this should be the E part of that. And this is the triangle V as 90 degree there. So the other parts are T and U there. These are the informations given in this example. Now they said that T plus E is equal to 90. T plus E is equal to 90. This is information given to us. And they said that sine of D is equal to 0.8. And you are going to find out cos of U for this part. So these are the informations. Now we can find out that this angle D plus this angle E is equal to 90 degrees. And this angle T plus this angle U is also equal to 90 degree. But they have given the T plus E is equal to 90. So this means if we use this information that T plus E is equal to 90, then D angle must be equal to U angle. So sine of D is basically equal to cos of 90 minus D, which is basically equal to cos of U there. And since sine D value is 0.8, so cos of U value is also equal to 0.8. In this question number 4, we are having this information there that three angles of a triangle are G, H, and 90 degree. What is the value of sine of G minus cos of H? So you have seen it there that G and H, they are unknown angles, but we have a trigonometric ratios there with the help of this property that sine of A is equal to cos of 90 minus A and cos of 90 minus A is equal to sine of 90 minus A. So we can write it here that sine of G degree is equal to cos of H degree, or cos of G degree is equal to sine of H degree. So we can have this property from this fundamental properties which we have defined it there as G plus H is equal to 90, or G is equal to 90 minus H, or H is equal to 90 minus G. So if we use this property into this question, then sine G minus cos of H, that should be equal to 0 because they are equivalent to each other. So our answer is 0 there for this question number 4. Sine of G is equal to cos of H, or cos of G is equal to sine of H. This is the property sine of A is equal to cos of 90 minus A. So G plus H is equal to 90. So G is equal to 90 minus H, or H is equal to 90 minus G. So sine of G minus cos of H, that is equal to 0 there. Now this question number 5. Two acute angles have measurements y degree and z degree, and cos of y is equal to sine of z. If y is equal to 7d minus 17 and z is equal to 3d minus 8, what is the value of d there? So we have this calculation. We know one thing that the with this property of this that sine of is equal to cos of 90 minus a, or cos of a is equal to sine of 90 minus a, this and this property. And here they have used already that sine of y is equal to sine of z. So we can write it as cos of y is equal to sine of 90 minus y. So cos of y is basically equal to sine of z. So that thing is equal to sine of 90 minus y, taking sine inverse on both sides. So z is equal to 90 minus y, or y plus z is equal to 90. Now we can put into this two equations which are given to us, 1 and 2 there. So one says y plus z. So we are adding both. So y plus z is equal to 7d minus 17 plus 3d minus 8. So y plus z is equal to 90. So that is 7d plus 3d, that is 10d minus 17 minus 8 minus 25. So 10d is equal to 115, or d is equal to 11.5. And you are going to find out the value of d for this part there. So these are the questions which are taken for this. Now we will solve the rest of the questions in the next part.